Good evening and welcome to this latest in a series of conversations from the Great Salt Lake Collaborative. I'm Roger McDonough. I'm a producer and host with KCPW Public Radio here in Salt Lake City. Tonight, as part of this series, we are talking about how the lake affects air quality, snowpack, and our ecology. Our panelists today are three experts on these topics. Here at the table, we've got Bonnie Baxter, who is director of Great Salt Lake Institute at Westminster College. She's also a biology professor at that institution. And Kevin Perry, an atmospheric scientist sciences professor at the University of Utah and an expert in the field of air quality. And then on the Zoom, we are joined by McKenzie Skiles, who is a U of U geography professor who focuses her research on the impact of dust on snow. And let me just say thanks to all of you for being here. Really appreciate it. Great. I do want to talk about the solutions eventually, or potential solutions in this conversation, but first we have to talk about where things are currently in terms of that problem and what that means for each of these areas. Dr. Bonnie Baxter, maybe we will start with you and a kind of overview of where things stand. I know that in the Salt Lake Tribune just yesterday you were quoted with some pretty dire information about where the lake is currently and how that is impacting biology on the lake. We've got some slides here, but do you want to kind of give us the broad understanding? I can start the slideshow if you'd like.
Yeah, sure.
Yep.
Sure. Yeah, you want to put the first slide up?
Yeah, hold on a brief moment.
Yeah, I'm happy to be here and sad to be having this conversation, but grateful. We have been... I've been studying the lake for 25 years, and I've never seen anything like this last year. This is, for those of you who can see the image, this is an image from the International Space Station that astronaut Alexander Gerst took back in 2017, so this isn't the current margins of the lake, but I wanted to throw it up there just to remind you that there's a section of the lake above the causeway that doesn't get the inflows from the freshwater rivers. And it's pink because it's at salt saturation, and only these pink microbes that I study live there. And so they're very vibrant purple, pink, and orange, and they make the water that color. So you can do microbiology from space in this picture, right? And you can see that the part south of the causeway, which is on the right half of the picture, is kind of this greenish hue. And in 2017, the algae were doing so well and flourishing, and that's what the brine shrimp and the brine flies eat. So the south arm is really what we're going to talk about today, because that's where the vibrant ecosystem is. That's where 10 million birds come to eat these two invertebrates, these brine flies and brine shrimp. Okay, go ahead. So the sad thing is we just hit our historic low, 4188.6 feet. The historic low prior to last year was 1963, which was 4190.3, and last year we went down to 4189 point something. So we are beneath last year's low. We went up a foot with the spring runoff, and then we went down like 2.5 feet. So one step forward, 2.5 steps back, I think right now is the story. So there's two major problems I'm following with respect to the biology of the lake. One is that the lake is shrinking, so there's less habitat, there's less water, and there's exposure of some of these microbes that feed the system. The second thing is that the salinity, it gets saltier. So one problem is that it's too dry, this desiccated part of the shorelines. The other is that the water is too salty. And so this last couple of weeks, we've been measuring 19% pretty consistently, 18.6, 19.1. So 19% salinity is super high for the south arm of the lake. It has vacillated until last year between 9 and 15% since I've been here for 25 years. And last year we ended with it being like 16.5 at the low point. Now we're up to 19%. The north arm, that part that's holding as much salt as it can, that's super salt saturated, in the summer it gets up above 30%. The ocean is a little more than 3. It's like 3.4, just if you need a comparative about what that percent number means. So 19% is super, super salty. And the microbes that feed this food chain aren't used to living at that high salt. Go ahead. So on the left side of this diagram, there are some brine fly larvae swimming in the lake, and they hatch into brine flies after they pupate on the bottom of the lake. And on the right side of the food chain, or the other food chain, is based on brine shrimp. So these are really the two keystone species of this lake. And those two invertebrates in the open water feed all of these birds that come, millions and millions of birds. And these birds fly on this Pacific Flyway, and this is the most important body of water that they visit. So we don't yet know what will happen to these millions of birds if this lake should completely dry up or get too salty to inhabit this life. So we're concerned about the brine flies, and we're concerned about the brine shrimp. A lot of attention is given to the brine shrimp because we have an industry here in the state of Utah, so there's a lot of good biology done on the brine shrimp. Lately, we've been focusing on the flies, and thank you, Pat Bagley, for your cartoon today about the flies. I appreciate you amplifying the message because we think they're feeding more birds than the shrimp are. The flies pupate on the bottom, so diving ducks dive down and get them off the bottom. They have larvae in the water column, so for birds that eat out of the water column, they can have flies too. Phalaropes sit on top of the water and grab the flies as they emerge. They also stir up the water and eat the larvae as well. And then finally, the shorebirds. As the flies blow in along the shores, there are shorebirds that eat the flies. That's a lot of different birds that are eating flies. So we think they're very important, and we don't have a brine fly industry, so no one's spent a lot of money and time studying them. Okay, go ahead. So what we think is happening with the brine shrimp food chain, and I've put little bullet points under each figure. So the algae that they eat are reproducing more slowly at this high salinity. They're under salinity stress. They're used to living in salty water, don't get me wrong, but when the water gets above a certain salinity, they have to work a lot harder to reproduce. So they're reproducing more slowly. And then the brine shrimp eat them. So the brine shrimp are dealing with food scarcity. If these algae start to plummet in the lake, then brine shrimp will have to look a little harder for their food. And they also will start to experience salinity stress. When I see shrimp that are in pools of hypersaline water as the lake retreats and these little pools dry up, the brine shrimp will be super small, and they'll be bright red because they're firing off these stress pathways, and they make antioxidants like beta-carotene, like we're supposed to eat in our diet, right? And that's to prevent oxidative damage. So when they're stressed, they're pink and they're small. They're not that normal sort of tannish color. So we're starting to see some signs, even though the population did pretty well this year, we're starting to see some signs that they could be stressing. Finally, the birds eat those shrimp, and eared grebes are shown in this picture. They seem a little less healthy this year, according to folks that are studying them. They seem dispersed. They're not all feeding in the same places they used to. But then the lake is shrinking, so their habitat is also changing, and we're not sure exactly why the changes we're observing are there. And so seeing who comes back next year and how they feed and how they do is really important. Next year's going to be a pivotal year. So we don't know if it's because the shrimp are smaller or because of habitat loss. So hopefully we can find out in the spring. This is the brine fly food chain. So it doesn't start with algae swimming around in the water column. It starts with these rocks on the bottom of the lake called microbialites, and they're lined with these microbial mats. So I've spent a long time studying those things. And at high salinity, these mats are crashing, and they're also being dried out as the lake shrinks. So we're seeing these little mounds on the shore with no mats on them. So the flies that eat them then are dealing with habitat loss because they pupate on those structures. And they can't do that if they're gone, right? If they're dried out of the lake water. The flies are smaller, they're lower in number. We think the pupa are smaller. That could impact their reproductive systems. Maybe they don't develop completely. So they're dealing with that food loss and that habitat loss and also salinity stress, just like the shrimp. And like I said, they're eaten by a whole lot of different birds. So I have a picture of a goldeneye and a phalarope and a gull on the shore flying, running through the flies. So there were hardly any adult flies around our ankles when we were out on the lake this summer. It was really obvious that they're diminished in number. And if there are smaller flies that aren't reproducing, they're certainly not going to be as nutritious for the birds. So we're worried about the birds and their diet. That's a close-up of a microbialite, so you can see the pupa on them. Kind of cool. Okay, go ahead. That's the microbialites last summer in 2021. Next slide. And that was just recently out at the lake. So it's a really different place in a really short period of time. So that's what I mean by habitat loss. Those structures are now out of the water. Okay, go ahead. That might be it.
I think that's
Yep,
it. Yeah.
that's all. So I hate to leave us on that devastating picture, but that is the picture of what we're seeing at the lake right now. Just the habitat loss, concern about the biology of the lake based on high salinity and desiccation. Thank you.
That final picture of the microbialites being entirely desiccated, and it's very frightening and hard to look at. And can I ask actually just quickly, do they bounce back? I mean, if water were to get there right now, would they? Obviously, the birds don't have the time to wait. But
Right. So we're studying this in my lab, and also Dr. Carrie Franz at Weber State has been studying this. We've been collaborating. What is the resiliency of those microbes and those structures? And we don't yet know the answers, but they do make this polymer. They make this sticky goo that helps hold the whole structure together. And one hypothesis that we have going in my lab is that biofilm that they're making helps protect them from dehydration. And maybe because bacteria can grow so quickly, and these are primarily made from cyanobacteria doing photosynthesis for the lake. 1/3 of the lake's photosynthesis will be lost if these structures completely crash. So that sticky goo actually might help seal them and help them stay hydrated and help them resuscitate. We know that the ones in the north arm that are at that extreme salinity are dead and there's no longer any cyanobacteria, but they've been at that high salinity since the late 60s. Okay. So we know it can be too salty for too long, but we don't know how long. A year, 2 years, if we get more water to the lake. I'm sure if we did that soon, they would rehydrate, but 2 years from now, I don't know.
I mean, I guess there's also a difference between too salty and just entirely dry.
That's correct.
Huh. Well, getting water to the lake is, the fact that there is less water is definitely going to impact what Dr. Perry studies as well. And so let's bring him into this conversation. Dr. Perry, you are an expert in air quality and dust. I guess we could jump into your slides here if you'd like as well.
Yeah, sure thing. So thank you for having me. And so I'm an air quality researcher, and I've been looking at the linkages between the shrinking Great Salt Lake and the air that we breathe, specifically looking at dust production. And if you'll take a look at that image of the Great Salt Lake, you'll notice that the lake is rather small compared to the brown area that surrounds it. That brown area that surrounds it used to be the bottom of the lake, and it was underwater as recently as the maximum for the lake in the 1980s. But I moved here 21 years ago, and 21 years ago it didn't look anything like this at all. I mean, the lake was still, I don't even know what it was, 12, 13 feet higher than it is now, sort of thing. And so this massive loss of water and the exposure of the lake bed is something that's really, accelerated and has become a big problem over the last, 10 to 12 years. And there's now more than 800 square miles of lake bed exposed. And to put that into perspective, the island of Maui in Hawaii is about 800 square miles. So that's what we've exposed out there. And if you have strong winds, and the playa, which is the word we use to describe that lake bed that's been exposed, is dry, then those strong winds can kick up dust storms. And those dust storms, next slide, are really visible. And here's an example from a picture that was taken looking basically North Salt Lake looking south. And this is dust that's moving in from the Great Salt Lake back in April of this year. That dust reduces the horizontal visibility, and I know from personal experience that if you have precipitation that associates with this, then that precipitation pulls that dust out to the ground. I see it on my car, I see it on my deck, I saw it on my garden, all those sorts of things, not to mention the fact that we're breathing that dust when it comes through. The Great Salt Lake is not the only dust source in northern Utah. In fact, it's not even the dominant dust source, but it is the one that's closest to the millions of people that live along the Wasatch Front. So it's the one that poses a very significant potential concern for exposure to that dust. Okay. So not all parts of the lake bed are dust sources. So we're actually fortunate that as the lake has receded, it's left a crust, a physical crust on much of the lake bed bottom. And that physical crust does a really good job of preventing the wind from being able to access the small particles that it can loft into the air. And as long as that physical crust is intact, then those parts of the lake actually don't blow. But the problem is that the longer that lake bed is exposed, the more likely that crust is to start to erode, and the more areas you have that actually act as dust sources. So I completed a survey of the entire lake bed in 2018, and at that time, only 9% of the lake bed was in a condition where it could actually serve as a dust source. So that's areas where you have an erodible shallow crust or no crust at all. And 75% of the lake bed is covered with a really fragile, thin crust. And so one of the things that I always try and get the message out there is that we have to preserve the crust. And so that means no ATVs, that means no motorcycles, that means no trucks, and trying to minimize the disturbance to that surface. And when I do my own field work, that's one of the reasons I actually ride a bicycle, because it's low impact for the crust that we're out there. So those dust hotspots that we have out there are not, huge areas. They're individual small areas, but those areas I've noticed this last few years are getting bigger over time. And eventually those small dust sources can merge into larger dust sources, so you have a dust area that's coming off the lake bed. And these are areas with essentially no crust or an erodible crust, little or no vegetation, because vegetation would tend to slow down the wind speeds, and the roots would help lock up the soil. And then you have to have small particles in the soil in order for them to become lofted. If you go to the beach and you grab a handful of sand and you throw it up in the air, all that sand simply comes back down. If you don't have small particles, if you add sand plus small particles and you throw it into the air, the sand particles will still fall right out, but the smaller particles will blow away. And it's those smaller particles that are brought in by the rivers. So the Bear River, the Weber River, and the Jordan River bring those smaller particles into the lake bed. And so it turns out that it's Farmington Bay and Bear River Bay where we have the higher concentrations of these smaller particles that can get lofted. The older sections of the lake, the Gilbert Bay and the Gunnison Bay, the northern arm, have less availability of these smaller particles, and so they're less potential for becoming dust sources. Next. But what we have here is the red dots are essentially the places where the lake is currently blowing. These are the dust hotspots. And you'll know that there's a big concentration of them in Farmington Bay right near where we're at today. There's a concentration of them up in Bear River Bay, kind of northwest of Ogden, south of Tremonton. There's also some on the extreme northwestern side of the lake, but those are quite far from where people are living. And there's a smaller dust area over on the western side, which happens to be near the U.S. MagCorp EPA Superfund site. And that dust has the potential to have other things in it that I haven't measured or people really haven't looked at in detail, sort of thing. And so the dust can be dangerous for a couple of reasons. One of those is just simple the fact that when you breathe particles, it interferes with your lungs. And if the concentrations of the particles are high enough, it doesn't matter what it's made out of, it can impair your lung function. The people that are most susceptible are those with asthma, COPD, the elderly, the young. But when the concentrations are high enough, it can affect everybody. And that's an acute response. And you've probably heard, or at least saw this article from this summer from the New York Times, where they were talking about toxic dust. And what they were referring to is some research that I conducted where identified, what is the dust made out of from the Great Salt Lake? And we looked at it and we analyzed 53 different elements, and then we compared those to EPA recommendations for what they see as potentially hazardous concentrations in the soil. And arsenic was the element that had the highest concentrations relative to the EPA regional screening levels. And this figure basically shows that the size of the bubbles are the arsenic concentrations in the soil. And the fact that every single dot is red means that every single measurement that I took of arsenic was higher than the recommendation values from the EPA. So does that mean we have toxic dust and we're all going to die? No, not necessarily, despite what the New York Times article said. What it means is that we have a contaminant of potential concern, that we need to have a much better understanding of how often that dust is transported to the surrounding communities, what those concentrations are when they receive them at the receptor sites at our homes. And then there's a third part of this, which is we don't know yet whether or not the arsenic that's in the soil can even interact with your body. We don't know if it's bioavailable. So we have to do further study to try and figure out what fraction of that arsenic is not locked up in minerals that don't interact directly with your body. So it's the dose that we receive that could lead to long-term health concerns with arsenic exposure. But that is a chronic exposure problem that will take decades to manifest itself, and it could potentially lead to increases in different types of cancer. Lung cancer, skin cancer, bladder cancer are the three that are most commonly cited for arsenic exposure. But I'm not advocating leaving the state because of the toxic dust. I don't advocate wearing a gas mask, but it is something that requires further study so that we can better understand the risks associated with exposure to the dust itself and to components of the dust like arsenic. So that's essentially, I think the point that I want to make here is that the dust is mostly lofted by strong winds that are often associated with fronts, weather fronts, cold fronts. And before the cold front gets here, we have strong winds from the south or the southwest. And then after that front passes, we tend to have strong winds from the west or the northwest or all the way up to the north. And so you have those 4 dust hotspots on each quadrant of the lake, and that dust will blow away depending upon the prevailing winds. So before the front gets here, we've got these winds from the southwest. It's moving that dust up towards Ogden, up towards Tremonton. And then after the front comes, then it moves the dust towards, towards Wasatch Front, the southern part of the Wasatch Front. And depending upon the direction of those winds, it can be everywhere from, Layton, Bountiful, Salt Lake City, or even Tooele, depending upon the direction of the winds. So we're all essentially downwinders when it comes to potential exposure from the lake. And this was a Bagley cartoon, which was based in part on the New York Times article about, let's go visit the scariest, the most terrifying attraction in Utah. The Great Salt Lake.
I think that's your last slide, yeah.
Yeah.
I know that obviously you talk about the crust that exists on the lake bed. You said that roughly 75% of the exposed lake bed has the capability of blowing as dust. Is that correct?
No, it's actually the other way around.
The other way around.
So 75% is protected, about 25% has the potential to blow, basically.
Yeah. And just on the question of water, the lack of water being the problem, obviously dust can't blow through water, but in some ways it sounds like you're talking about the crust itself being as important as having water on the lake.
So if you want to try and prevent dust emission, the most important thing is to have the lake bed covered with water. If it can't be covered with water, I want it covered with a crust because it does a fairly good job, at least in the short term, of preventing the dust emission. But once you start to lose the crust, then it's so salty that we can't really have a lot of vegetation out there. So it really becomes kind of an uncontained dust source.
How about in terms of consistency of water coverage? If there's some water, then less water, then some water, does that mean less crust and more dust?
Actually, this summer, I went out and visited the same places on the crust 22 times. And what we noticed is that when we had rain or we had water that moved across, it actually helped the crust reform. And so periodic wetting seems to be something that helps that crust reform. So it's not just a all or nothing, a one-way degradation, but we do notice that a dust hotspot that we see one year, you come back the following year, it's there and it's bigger. And so there is a gradual expansion of these dust hotspots, but there is the ability to temporarily recrust those areas.
Okay, and then one final question before we bring in Dr. Skiles here is, residents who are concerned about the dust itself and the makeup of the dust, is there monitoring happening right now? I mean, they can go to airnow.gov and see what the air quality is, but in terms of keeping an eye on whether or not arsenic-laced dust is showing up in their backyard.
Actually, the air.gov actually doesn't do a good job of even capturing the dust itself. Because much of the dust is what we call PM10 dust, which is basically larger particles, and the state really doesn't have the real-time monitors for the PM10 dust, the larger particles. They only have real-time monitors for the PM2.5, which are the smaller particles that we usually associate with a hazard. And the other problem is that when the winds are from the south, it's moving that dust towards Ogden and north, and we don't have any monitors up in that region. So the placement of the monitors is problematic. The lack of real-time monitoring of the PM10 is a problem. So we don't really have an effective mechanism to warn the public about the incoming dust. But on the flip side, the dust storms don't typically last 24 hours. They're shorter term events for the most part from the Great Salt Lake, and so there is a potential to actually shelter in place if you are aware, or donning our N95 masks. They do a pretty good job of protecting us from those particles in the air.
Okay, I lied about the last question. How many of these events per year are we talking about?
So that's an area of active research. Because we don't have the monitors located in their proper places, we don't actually know that answer. And it's going to be quite variable from year to year, depending upon the weather patterns that we have. But we don't know the answer yet.
Okay.
Yeah.
Thank you again, Dr. Perry. And just in the interest of time, I think we will press pause on that discussion, and we will turn to our third panelist, Dr. McKenzie Skiles, who joins us via Zoom. And Dr. Skiles, Kevin Perry is looking at the makeup of the dust and the potential human health impacts. You study dust, but for an entirely different reason. And I should probably open up your slides here as well. You are looking at the impact of dust when it lands on snow, correct?
Exactly. Yeah. So, well, first of all, I'm sorry I couldn't be there in person, but I'm glad I could join virtually. And I'll wait for the slides to expand out. Yeah. So the process that I study is there's this sort of window in time in the spring when we are getting dust from these source regions that are drying out after the winter, and we still have snow in the mountains. And when we get dust blowing from arid or disturbed landscapes, and this picture I'm showing is dust coming off of the dry lake bed of the Great Salt Lake, it can land in the snow, and you can see these individual dust layers within the snowpack. Each layer corresponds to an episodic dust event that occurred. And this is a picture from last winter. So if you hit next. So this is just a diagram that sort of explains the impact that dust has on snow. So snow is actually one of the brightest natural surfaces on Earth, and that's what the left side of this diagram is showing. If we think about incoming sunlight as being 100%, fresh snow will reflect 90% of that. So, I mean, we can think about it. We all know snow as being really bright and white. If we put dust or anything darker, which is basically everything, onto the snow surface, then we increase the amount of sunlight that's absorbed. And by increasing the amount of sunlight that's absorbed, we actually speed up the rate at which snow ages, essentially, and that also makes it darker. That's known as the grain size feedback. And in combination, those two impacts, the visible darkening that we can see and this aging impact, accelerate snowmelt. And that snowmelt acceleration exposes the darker ground surface earlier, and the ground will then absorb more sunlight and melt snow faster at the edges. So there's all these feedbacks that are involved that are very effective at advancing snowmelt. And I've been lucky enough to study this impact all over the world. And I wasn't necessarily expecting to start at the University of Utah in 2017 and have an event from the Great Salt Lake catch my eye. So if you go to the next slide. In 2017, the spring of 2017, I was actually on campus at the University of Utah, and I was looking out towards the Great Salt Lake, and I noticed a dust event. And it was right around April 15th, and it's funny timing because we almost always have a dust event around April 15th, and we call it the tax day dust events. But we had this a pretty dramatic reduction of visibility in the valley. And then when I went up to my study plot at Alta, I noticed some dust layers in the snow. And I was like, oh, I saw dust blowing off of the dry lake bed. You know, I wonder if we can choose this event and study it in more detail to understand how dust from the dry lake bed might be impacting snow. So we targeted this one event, and I was able to reconstruct snow evolution, and that's what this plot is showing is snow depth. I was able to reconstruct snow depth in the sort of if dust is there and if dust wasn't there. And we showed that one single dust event accelerated melt by 5 days. And a portion of that dust event had come from the dry lake bed of the Great Salt Lake. So I'm going to use this as a baseline study, and then I'm going to talk about this past winter. If you go to the next slide. So this was one of the snow pits from last winter. And since 2017, we've put in additional instrumentation and started monitoring the snowpack in much more detail. And last winter caught our attention immediately because we had more frequent dust events and more dust was contained in each one of those dust events. So what we do is we collect samples, snow samples at each one of these dust layers. We bring it back to my lab and we filter them out, and then we measure how much dust is in the snow. And we quantify that as a dust concentration. And just for comparison, these are some of the filters from 2017 versus the filters from last winter. And you can see there's just so much more dust on the filters in 2022. So it's not only that we got more dust events, but there was more dust contained in those dust events as well. So if you go to the next slide. So we were able to work with, collaborate with some folks in the atmospheric science department to simulate where this dust was coming from. And we combined all of the dust that we had seen from last winter. And we looked sort of what we call back trajectories. We simulate where the dust could have come from that we see in the snowpack. And when we summarized events, all of the events that we saw, what we found is that about a quarter of all of the dust was coming from the dry lake bed. And that's a dramatic amount, but it's obviously not all of the dust. But I think what's more important to think about here is that by area, if we think about the area that's actually contributing the dust, it was by far the largest contributor. So these other areas that we get dust from, that we've always gotten dust from, it's like the Great Salt Lake Desert or other playas that are south of us, those are sort of what we think of as natural dust-producing regions that maybe some surface disturbance would contribute to the amount of dust we see from those areas, but they're arid already and could be producing dust if we get high enough wind speeds. The Great Salt Lake, on the other hand, wouldn't normally be a dust-producing region if there was water in the lake. And we can only see this as not getting better, but getting worse through time. So this is sort of a harbinger of what is to come. You can go to the next slide. So we did the same modeling for 2022 that we did back in 2017, but we did it for the whole season for all of the dust events that we saw. And there's a lot of lines on this plot, but the important ones to look at are the brown one, where that's snow with dust, and the green one, and that's snow without dust. And the difference in meltout was 17 days, so more than 2 weeks. And if people there can think back to last winter, there was actually quite a few snowfall events in the spring last winter, and that minimized the impact of dust because we would get a dust event and then it would snow on top of it. And when it gets buried, it's not accelerating snowmelt. Then we'd get another dust event and then it would snow on top of that. When it was exposed, it melted out really rapidly as soon as all of those dust layers came to the surface. And so if we hadn't had that frequent snowfall, that was actually doing us a favor. If we hadn't had that frequent snowfall, the impact would have been greater. And the reason why this is so important for us in the Salt Lake Valley is that almost all of our water comes from snowmelt, and almost all of the water that recharges the Great Salt Lake comes from snowmelt. And so we're sort of figuring this out as we go along, but this relationship between the Great Salt Lake and the adjacent Wasatch Snowpack, they're important for each other. You know, there's lake events that come over, snowfall lake events that come over the lake, and we get sort of hot spots of snowfall from those, and then that snow is what's running off back to recharge the lake. But if we're using that water between when it runs off before it actually reaches the Great Salt Lake, then we're never going to get back to these higher lake levels that we've had in the past.
Dr. Skiles, I'm assuming that's your last slide there, and I think so.
Yeah.
A question that I have for you on this is, 17 days. I noticed that this is in June, from June 7th to June 24th. I'm wondering if we have similar events in the winter. And I mean, more than 2 weeks of advance runoff. We rely, obviously, on the snowpack to serve as a kind of water storage through the summer months. If that was accelerated even more, that would have an impact there. But yeah, does something similar happen in the winter? Is that something that we can look at?
So we don't see that many dust events in the winter, typically because precipitation also will wetten the dust source regions. And like Dr. Perry was talking about, if you wetten the surface, then you get less dust from it. It's a natural crust. And so it's rare to get dust events in the wintertime. Is also wind speeds tend to be a little bit lower in the winter. In the spring, everything becomes a little bit more active and we get these prefrontal winds. And the prefrontal winds are the high wind speeds that are most likely to pick up dust and deposit them in the snowpack. And the timing of it is really relevant because that's when days are getting longer and we have more sunlight. And it's that absorbed sunlight that actually controls the rate of snowmelt. We often think of it as temperature, but it's actually absorbed solar radiation that controls how fast snow melts. And it's not just timing, but when we melt it faster due to dust, it comes out quicker. So we're shifting both timing and magnitude. And our current runoff forecasting models don't account for this process. So that can result in large errors in actually forecasting when the water is going to be coming out.
And am I right that in other parts of the West you have seen even more dramatic advanced runoff, meaning accelerated runoff in Colorado, for example?
Yeah, so in southwestern Colorado, the dust is coming primarily from the southern Colorado Plateau. And anyone who has been to southern Utah or the Four Corners region can picture that red dust in their mind. It's red rock landscape. And the soils in that region are very iron rich and darker than the sediment that we usually see in playas. And that darker dust will have a more dramatic impact on melt than the brownish or yellowish dust that we see here in the Wasatch. And the impact on melt in the southern Colorado Rockies is more on the order of 1 to 2 months from dust deposition.
Okay. I said that I do want to save time for audience questions if there are any, but I said that I wanted to try and get to solutions here and what we might be doing to, and this is like both the hardest and the easiest part, because the simple solution is we need more water on the lake bed to prevent dust, the dust that's accelerating snow melt that is impacting potentially human health. And of course, water at the lake is going to preserve that ecosystem. But I'm wondering, Bonnie Baxter, there are some solutions that are being put in place already that we've been trying to see come online in terms of a trust, for example, that will pay for water upstream to come down to the lake, or conservation efforts. But given what you've said, I mean, this is, okay, I'm taking it away from the solutions conversation, but given what you've seen, are these solutions coming too slowly, not fast enough? Are we not seeing them happen quickly enough? Like and Dr. Perry has a point on this as well.
Yeah, I just want to step back and say, before you can actually go to solutions, you have to understand how we got into this mess in the first place, and then we can talk about solutions. And it's really easy to say, oh, this is due to climate change, or this is due to the mega drought. But the problem with that is that if you add up the amount of water that we divert and deplete from the incoming streams before that water reaches the Great Salt Lake, we've actually run a deficit of, it's a strange unit, but over 400,000 acre feet of water a year is what we've been losing from the Great Salt Lake. And there was a study done up at Utah State that basically said that, if we have 100% normal snowpack, because we divert too much water, the Great Salt Lake will shrink. We actually have to have 130% normal snowpack just for the Great Salt Lake to not shrink in a non-drought year. So that's clearly not sustainable. And it comes back to where we have an unhealthy relationship with water. We live in the second driest state in the nation, and we treat water like it's always going to be available. The mega drought that we're in right now is a contributing factor, but mega droughts are part of the natural cycle of weather in the western United States. We know that from looking at tree ring analysis. This just happens to be the first mega drought that we've had since this valley was populated by the pioneers in the mid-1850s. It also happens to be the worst mega drought that we've had in the last 2,000 years, which some scientists say has been accentuated by climate change. Since this is not being driven by climate change, it's being driven by our choices on how we use water. That's one of the things that makes me optimistic that we actually have levers that we can pull to alter the equation and to make substantive changes that can ultimately put water back in the lake. I think that's kind of the good starting point.
Great. Well, levers to pull, and we are trying to pull them, but maybe I'll go back to the sort of less than optimistic question, which is, are the solutions that are in place not actually solutions, or are they just not working fast enough, Dr. Baxter?
Yeah, I want to add on to what Dr. Perry said before I answer that, which is, it is true that we've got ourselves into this mess, and it's up to us to get ourselves out of it. And I think that's really well framed. But it's also true that Great Salt Lake is not immune to the pressures of climate change. So it is actually both things. I mean, it's not that this is happening in a vacuum, right? We're also experiencing the pressures of climate change, warmer summers, higher evaporation rates. And with what Dr. Skiles talked about, if you have a mistimed snow melt and lots of runoff, that's more evaporation, and that's happening in the context of climate change with warmer summers, for example. So the problem is we've not set ourselves up for success to handle these pressures that we're experiencing now. So we do need to do what we can do, what we can control. We need to do that now. And the question about, is it too late? What we saw based on just the brine fly food chain that I talked about this summer was devastating. And I think that, we brought in an expert to look at these flies and to tell us what was going on. And we've set up experiments in our lab, which we'll continue to do. And my colleague at Great Salt Lake Institute, Carly Beadle, is heading up Team Fly. And so Team Fly is taking this very seriously. She has some students working with her and collaborators. And we're really going to work really hard to be ready for brine fly monitoring all next season. So we'll let you know. But what we're seeing thus far is not encouraging. And the only way to get the salinity down is to get water to the lake. So these solutions that have to do with water rights, purchasing water rights, changing policies, changing laws, maybe even pricing structure of water, those solutions do take a minute to see the impacts of, right? So it's not instant, and it's hard to measure. If you give farmers the ability to lease back their water rights without losing them to the state for the lake, that's a personal decision to do that. It comes down to individuals, right? So I think it's hard to quantify.
Are there, I guess maybe a question that I'll throw to both Dr. Skiles and Dr. Perry is, are there things that, Bonnie Baxter is talking about the fact that it's sort of, they take a minute, these solutions don't happen overnight, but I'm wondering if, given the magnitude of the situation, if some more urgent emergency action is something you would advocate for. Are there things that should be being done that aren't being done in your opinions, and can you talk about this? Dr. Skiles, I'll give you the first bite at the apple if that's, I know it's a really difficult question.
Sure, I think, there's a few things. The state of Utah is not the greatest at releasing data on who uses water and when. And there are some states where that information is open and publicly available. We do know that a lot of the water is used by agriculture. Most of the water is used by agriculture, and some is used by domestic sources, which I think is something that has been misrepresented in a lot of the news articles about the Great Salt Lake. They make it sound like it's, people watering their lawn too much, which is not necessarily the case. And so I think that we need to, we can think about when the water is needed and when it comes. And maybe, one of the solutions that relates to what I study is maybe this initial snowmelt pulse, we could just let more water run out into the lake and not take all of it up. So there's this pulse that comes on all of the three main rivers that provide water to the lake. And we could let more of that run out to the lake until some level is reached and sort of put the lake and its needs first, which we've never done before. And so that's one option. And then, of course, just knowing where the water goes and when, actually caring about who is using the water and when, which is not something that we fully track right now. Nobody really appreciates the value of water when we should. And putting that in the forefront, I think, is one of the solutions. It's not, the most appealing answer is we need more data, but I think that is the answer.
Secondary water metering, that kind of thing. There is metering that's happening that hasn't happened before, and that should have an impact. But Dr. Perry.
Yeah, I just want to follow up, looking at agriculture, because agriculture does use about 80% of the water. So, we could completely cut off every domestic faucet in northern Utah, you cut down that 20% use, and it's still not enough. So we all have to contribute to this. We all have to participate, but agriculture has to, be at the table and a willing participant. And I'm actually enthusiastically, a little bit positive about the reception that farmers have had to trying to conserve water. There was a bill that was passed and signed by the governor last year to provide infrastructure money to improve the delivery of water to fields so that they could have less evaporation and less water losses in the systems. And that money that was provided by the legislature required 50% matching from the farmers. And they had way more farmers that wanted to participate than they had funds available. And so farmers are willing to invest in improvements, but the state legislature needs to help incentivize that as well. And then, since they've changed the water law to allow farmers flexibility on what they do with that conserved water, the next step is to try and incentivize moving that water and shepherding it to the Great Salt Lake for water that is conserved from the agricultural sector, from investments that are made with public money.
How about in terms of things that aren't being done that you think could be being done? Wow, being. Yeah. Is there something along those lines that you think of and you think this is kind of pie in the sky, hard to get to, but boy, if only we could do this one simple trick?
It's the same issue with air quality. There's no one air quality pollution source that we can treat in order to improve our local air quality. In this case, there are many different stakeholders, there are many different users, and we all have to kind of pull together in order to do that. That being said, the Great Salt Lake Advisory Council came up with a 12-step program for how to save the Great Salt Lake, and the state legislature last year kind of knocked off the first 3. There's still more that needs to be done, and there's a roadmap to do that. There was also the state legislature had HCR 10, which was an authorized a study to try and come up with ideas on things that could be done. And they came up with a list of more than 75 topics and things that could be done to try and shepherd more water to the lake. And to date, we've knocked off a few of those. But we have roadmaps in place. We have the will of the people to try and save the Great Salt Lake. We've been working on education outreach, and the Speaker of the House, Brad Wilson, basically said that one of the things that they're doing now is trying to have a concerted water-wise campaign to educate the public on issues associated with water conservation. And so I'm cautiously optimistic, but the need is urgent based upon what Dr. Baxter was talking about in terms of the potential collapse of the ecosystem.
Which may be happening right now. I want to save time for questions, but Dr. Baxter, I have a one throw-off question for you, which is there anything that you don't want to see done to save the lake? Meaning any specific bad ideas?
Oh, wow. Oh, that's a hard one. That's a hard one. I think there's a lot of talk about, could we make the South Arm less salty by sealing off parts of the lake, for example? There's been some conversation about that. There's also been some conversation about could we pipe in water? And the first person who mentioned that to me said, yeah, and these, okay, so background, I get hundreds of random emails and phone calls from people. And some of these ideas are really, really good. And some of them are not so good. But one person told me, we get too much water, we get too much rain in the Northeast, and we don't get enough rain in the Southwest. So could we pipe some of that water out here? And I'm like, I'm no engineer, but that sounds expensive. And then he said, well, we do it with oil. And I'm like, ooh, what an excellent point. I mean, we pump oil all the time and traverse whole countries with pipeline. So could we pipe water? I don't know, because it's not my field. But this idea of piping water from the Pacific Ocean, I think is the bad idea. And I think that because it also would bring salt, and then we don't need any more salt, not to mention how expensive and uphill and all the engineering battles that seem problematic. anyway, that's one that I'm not so sure about.
I'm not going to ask any more questions. I'm going to now turn it over to the audience to see if they have any questions, and for our panelists. And you can direct them at a specific panelist or to the whole group if you happen to have one. And there's a microphone over here that we've got as well. Anybody? Just raise your hand if you have any questions. And yeah, sure.
You probably already addressed it. I came in late. My name is Jim Webster. I wrote the master plan for the Great Salt Lake State Park, if you're aware of that.
I am aware of that.
Oh, are you?
Thank you. Nice to meet you.
Anyway, I was just curious, how much water is lost by infiltration in all of the feeders that come in from the various watersheds? And are there, I realize a lot of it is in culverts as well, but is there a disadvantage in utilizing bentonite or some other sealer to minimize the loss in infiltration?
I'm wondering if Dr. Skiles could answer that.
It's a good question, and I don't actually think we know the answer. In years that are drier, like now, and we've had winters where we've had multiple low winters in a row, we lose more water to infiltration because the soils are drier and they dry out earlier. We do have a lot of infrastructure, especially on the Jordan, where a lot of it is concrete culverts. So in those systems, we're not losing water to infiltration. But say on the Bear, I don't think we know the answer to that, and I think it fluctuates from year to year.
Well, it might scour out in some places anyway, but it just seems like that might be a more effective way to transmit water without losing it to infiltration. I realize, that's probably a very expensive thing to do.
Mm-hmm. Very good question.
Anyone else? If not, we can wrap it up. I should say there's some housekeeping here to point out, but do any of you have any final comments you want to make before we shut this down? Yeah. Go ahead.
Yeah,
Dr.
so when I moved here 21 years ago, I asked my friends, should I go out and visit the Great Salt Lake? And they're like, why would you want to do that? It's stinky, it's buggy, it's not a great place to go. And so for the first 10 years I lived here, I took their advice and I didn't go out to the Great Salt Lake. And then I started going out there. And what I experienced out there couldn't be the more opposite in terms of the amount of wildlife that's out there, the serenity, the recreation opportunities, the types of people that I meet when I'm out there. It's just an absolutely incredible jewel that we have, and I just want to encourage everybody from Utah to go out and visit the Great Salt Lake, to learn what it has to offer. And I think the more people do that, the more people will start to care and get a sense of urgency that we need to do something now.
Well, let's actually first give our panelists a round of applause. We've got Dr. Kevin Perry, Dr. Bonnie Baxter, and Dr. McKenzie Skiles. Thank you all for being here. This event was part of the Great Salt Lake Collaborative's mission to educate and inform people about the lake. You can find videos from previous panels from this series at the Collaborative's YouTube channel. These include a discussion hosted by Fox 13's Ben Winslow entitled Can We Save Great Salt Lake? And another moderated by KUER's Elaine Clark on the history of the Great Salt Lake. They're both worth watching. The next conversation will take place at the Syracuse Library in Davis County. Journalists from the Salt Lake Tribune, Deseret News, and Fox 13 will share some of what they learned on a recent reporting trip to Owens and Mono Lakes in California, and what can be learned from those saline lakes to help ours. Again, that is next Tuesday, November 15th from 6:30 to 7:30 p.m. at the Syracuse Library in Davis County.
Does the Salton Sea fit into that equation at all?
It's a great question, perhaps for a saline lakes person. Bonnie Baxter, do you want to jump in there?
Just fit into the equation how?
Well, I mean, you're looking at two dry lakes. And,
Yeah.
Yeah. See the movie Chinatown. But
But the movie,
Salton Sea is also losing, isn't it?
It is. It's retreating quite quickly. In fact, the tilapia industry crashed there. Lots of bird populations now divert and don't go there. It is in this series of saline lakes from Lake Gay Bear in Oregon down to Mono and those Sierra Nevada salty puddles of water along the way. And yeah, the Salton Sea fits in there.
Most people have never heard of it.
Yeah, I just talked to somebody from there today, in fact. So yes, thank you. And it is important to think about this as a system of saline lakes, I think.
Thanks again to everyone for joining, and learn more about the Great Salt Lake Collaborative at greatsaltlakenews.org. Thanks.